Happy morning to Honorable Cynthia. Today we are going to see about Newton's second law of motion. Definition of Newton's second law of motion. According to Newton's second law of motion, Newton's second law is the rate of change of linear momentum of a body is directly proportional to the external force applied on the body, and this change takes place always in direction to the applied force. Now we are going to see the mathematical formation of Newton's second law. M is equal to mass of the body. F is equal to an external force applied on the body which is constant in magnitude. T is time for which the force is applied. V is equal to final velocity of the body along the same straight line after t seconds. U is equal to initial velocity of the body along a straight line. Initial linear momentum of the body is equal to P1, that is equal to mu. Final linear momentum of the body is equal to P2 minus P1, that is equal to mv minus mu, that is equal to m into v minus u. Now, as we see, the rate of change of linear momentum is equal to m into v minus u by t. But v minus u by t is equal to change in velocity by time taken. That is equal to rate of change of velocity, that is equal to acceleration of the body, that is equal to a. Therefore, from equation 1, rate of change of linear momentum is equal to m into a, in which two factors the acceleration will depend on. Okay, let's say there is an object on table, you apply a net force of 10 units on it, and then you apply a net force of 20 units on it. In which case do you think the acceleration will be more? Of course, the one in which the force was more. So we can say that one of the factor is net force. It is more than more will be the acceleration. If it less, then lesser will be the acceleration. Acceleration depends directly on the net force. Come on. Now I want you to think of the second quantity. The acceleration will be depend on, let's say there are two objects on the table. One has a mass of 3 kilograms and another has a mass of 5 kilograms. Now if you apply a net force of 10 units on each of them, which one do you think will accelerate more? Surely it is the 3 kg one because it has the lesser mass. Lesser the mass, more the acceleration. Or more the mass, the lesser the acceleration. Hence we can say the acceleration depends inversely on the object's mass. These two are an examples for Newton's second law of motion. While seeing this picture, what can you think of? This is an example of Newton's second law of motion. When a man hits a tennis ball, because of less mass, a tennis ball accelerates forward easily. When a man hits a football, because of more mass, a football does not accelerate forward easily. It means that acceleration is inversely proportional to the mass of an object. More the mass an object has, the less it will accelerate. This thing shows us the presence of Newton's second law of motion. Thank you.